All right. So, in order to be able to understand what we're going to do in chapter 7 with work, we need to go back and talk about vector multiplication. And so you were supposed to read through that section. And I just think that there are some parts of it that are better when maybe I go through them again and explain them. So there are going to be a number of videos to kind of help you basically teach this to yourself. And then we'll use it in class. So we talked about back when we were first learning about vectors that we could multiply vectors by scalars. If I had some vector v and I multiplied it by a 2, which is a scalar, then that would mean that the magnitude of v was twice as long. If I took my vector v and I multiplied it by a -1, that would tell me that my vector pointed in the opposite direction. What we didn't talk about is what we would do if we took vector v and vector u and multiplied them by each other. And there are two ways we can do that. We can do what I've written here, which is the scalar product, which is what we're going to talk about today. Or I can have a vector product, which is something that we'll come back and talk about several chapters from now. Okay, but today we're going to focus on the scalar product. And it's called a product because I'm multiplying two things by each other. And in this case, it's going to be two vectors, v and u. But it's called a scalar product because when all is said and done and I've done with my multiplication, I'm going to end up with a scalar, which means I'm going to end up with a single number. So it's important when you're writing about scalar product that you use this dot here. If I was going to multiply two numbers like 3 and 5, I've been trying to get you to write them that way. Okay, I don't want you to write 3 by 5 or 3.5. Okay, and I don't want you to write 3 times 5. Okay, those are not the way we're going to do things anymore. So you must put that dot in there if it is a scalar product. If you don't do that, then what you're writing is nonsense and gibberish. So this is not an opportunity for you to make up your own way of writing things down. You must do it the way that I and the book tell you to do. Okay, so let's talk about how this works. Okay, so I'm going to have one vector here that's actually going to be my vector b. Let me write that a little bit better. Okay, and I have another vector over here that's going to be vector a. And those vectors are going to be separated by an angle theta. Actually, they're not. They're going to be separated. It's fine. It can be separated by an angle theta. Okay, so when I take that dot product or that scalar product, and we call it a dot product because the symbol that we use is a dot, that's going to be the magnitude of A times the magnitude of B times the cosine of the angle in between them. Okay, which sometimes we write AB cosine theta. And it doesn't really matter what symbol we use for the angle. So what we're effectively doing is projecting one of the vectors onto the other and then multiplying the components that are in the same direction. So if I took A and I projected it onto B, which means I drop a perpendicular, and then what I have is a little right triangle, and I break A into its components, then I would say that this might be, for instance, AX. Okay. And that's going to be equal to A cosine theta. So I could come over here and say that my dot product was A cosine theta times B, which I can do because regular multiplication is commutative and associative. So I can clump different things together. I can multiply them in different orders. Okay, so this is the part of A that projects onto the direction of B. Okay, and I can do something similar with my A direction. And I think what I'm going to need to do, though, is I'm going to need to move this down a little bit. Okay. So what I can do is kind of extend the direction of A, and then I can drop a perpendicular from B onto there. Okay, so that again, I have this right triangle. And then this side here would be B cosine theta. So I could also write my dot product as A times B cosine theta. Okay. So it isn't really important that you understand this whole part about the projection, but I think it's important that you understand where things come from. Now, one more thing that's going to become important is what the SIGN sign is of A dot B. And again, we've talked all the way through about setting things up properly and respecting things. Okay. If you put in theta, whatever it is, however it is, somewhere between 0 and 180 degrees or 0 and pi, your calculator will probably pop out with the right SIGN sign for cosine theta. And whatever that sign is what the sign of my dot product is, or my scalar product. So a scalar product can be positive or negative, and that will have implications for the physics. Okay? All right, see you in class. Thank you.